Okay, welcome back, kiddos. Now we are starting Unit 6. So we're going to start with what we call special segments. So we have some special segments inside some triangles. So the first thing that we're going to talk about are some vocabulary words. So I want you to take a couple highlighters today and choose a couple colors that you like. So the first one I'm going to use is for when we're doing vocabulary words. So bisect. What does bisect mean? Think about from last semester what we talked about bisect. Of course, bisect means to split into two equal parts. Okay, and it whenever we bisect something, it may be an angle or it could be a segment. Okay, so we're going to talk about both of those today. Okay, so the first thing we're going to talk about is an angle bisector. So let's go ahead and highlight that for another vocabulary word. So an angle bisector. Okay, as we talked about, a bisector cuts into two equal parts. So an angle bisector would be a segment or ray that splits an angle into two equal measured angles. Okay, so it's going to split that angle into two equally measured angles. So if we look at it right over here, the angle bisector on this is going to be AD. Okay, so AD is our angle bisector. Okay, and we know it's an angle bisector. Here's how we're going to think about that. Here's how we're going to think about that. This is our hint. Okay, this is what we're going to be looking for, these arcs. Okay, that's what tells us that it is an angle bisector, because we see that tells us those are two equal angles, so we know this is the angle bisector. So on this one, what we can say is that this ray right over here, AD, so we can say AD bisects angle BAC, right? BAC is the big angle, and so this bisects it. So what that means is it makes two different smaller angles, right? So BAD. So we'd say angle BAD is congruent with the other angle that it created, right? DAC. Okay, so that's what an angle bisector does, is it splits that, it's a segment array that splits that angle into two equal angles. All right, so let's get into an example of that practice first before we go into a median. Okay, so on this one, let's check out this example. Okay, so let's go and label this one, we do number 1. Okay, and we can go ahead and highlight it with that one color. All right, so it says segment BD. So BD bisects ABC. So let's draw that in. We're going to say this bisects angle ABC. ABC gets bisected. So we can say that angle is congruent with that angle. Okay, so we know we're dealing with an angle bisector. So there's called an angle bisector theorem. Okay? That's what we're going to use with this one. What they want us to do is they want us to solve for x. So they want us to find the length of this. If this bisects, if this 18 and this is 19 and this is 11, they want us to figure out x. They want us to round it to the nearest tenth. Okay, so what we're going to say with the angle bisector theorem, that tells us that it divides the opposite side into proportional segments. So what that means is if this is an angle bisector, it's going to make these into proportional segments. So let's go ahead and solve that. So I got this. We're going to have two different ways we can do it. So what we're going to do is we're going to set up, either way, set up a ratio of the two sides and these new segments. Okay, so we got two different ways we can do it. So let's look at over here. We have 18 and 19 and x and 11. So I'm going to set up my two ratios. Okay, so we said we're going to set up a ratio of the two sides. So let's look over here. I have 18 on this one. If we look at it, this makes two different triangles, right? It makes this triangle right over here. Okay, and it makes this triangle right over here, right? So these two sides, I'm going to put 18 on here since that's on my left side. And I'm going to put 19 over here since it's on my right side. So I'm going to look at those numbers, 18 and 19. Now I'm going to concentrate on these two numbers right over here. Okay, so since this is the angle bisector that we're talking about, it makes proportional segments. If 18 to 19 is proportional with x to 11. Okay, so I'm just going to go over here and I'm going to say x and 11. Okay, so this is a way that we're going to solve a lot of different things going forward. Anytime we're trying to solve for x and it looks kind of crazy, we're going to cross multiply. And so here's what we're going to do. We are going to just think. Okay, we're going to think this times this equals this times this. Okay, so anytime you have a fraction equals a fraction, we just cross multiply. So I like working with my variables first. So x times 19 is the same thing as 19 times x, right? So 19 times x is written as 19x. And that's going to be equal to 11 times 18 or 18 times 11. And that's going to give us 198. Okay, so once we do that now, it looks quite simple, right? We know to get x by itself, we're going to do our final step, which is dividing by that coefficient, right? So we're going to divide both sides by 19. Those cancel out. So x is going to be approximately 10 point, let's write down three numbers, 10.421, 3 decimals. Okay, but we know the tenth means one digit, right? One digit past the decimal. So that means our answer is going to be x is approximately 10.4. Okay, so that's how we do it. So that's the first way. Now, what if you said that you wanted to set up a ratio a different way? What if somebody told you that you could set it up a different way? Here's the second way. Okay, what if I told you I can say 18 is relative to x because this is the same one. So I could say 18. You have 18 on top, and I can have x over here. Well, if I started with this side over here on this one, over here, then I need to have this other side over there, right? So I'd put 19 over there. Okay, and then since I have x going with this 18, right, then I would have 11 going with that 19. Okay. Now, it looks different, right? But if we solve it, it goes the same way. I would have 19 times x, which would give me 19x. And then I would have 11 times that 18, which would give me that same 198. So that would still give me that x is approximately 10.4. So either way that we do it, we're going to get that same answer. Okay, so that's all we do. Whenever we have an angle bisector, it tells us we're going to use the angle bisector theorem. That means we're going to set up a ratio between those sides. So let's go ahead and highlight that vocabulary word, and let's use a different color for our answers. So those are our final answer. I like using green. Green's a nice getting the money, right? Good, green is good, so green for that. So that's the first one that we're going to talk about, and that's with the angle bisector. Okay, so next we're going to talk about median. So let's go ahead and highlight this one with the blue, median. Okay, so a median is a segment from a vertex to the midpoint of the opposite side. So to the midpoint of the opposite side. Okay, so if we look at it right over here, we said it goes from the vertex to the midpoint of the opposite side. So that's a vertex, right? We know the vertex is when we have the corner of an angle, and it goes to the other side. So it goes from one to the other, and it divides it into two equal segments. Okay, so if we see this right over here, this tells us that those are equal. Okay, those are equal segments, and this will be our segment. That's our median. Okay, so we talked about an angle bisector is something that splits an angle. So this splits this angle into two, and a median is a segment that splits a segment into two sides. So this median right over here splits this. I know it does something to this angle, but what we're talking about is it splits this side into two sides. Okay, so if they're two equal angles, let's get right into an example on this. Okay, so right over here, this is going to be our we do number 2. Okay, so our we do number 2, it says that segment BD is a median. Okay, so we know if BD is a median, right? So we're talking about, let's go ahead and highlight that, BD right over here. If it's a median, that we know that these have to be equal segments, right? So if it's a median, then we know that these sides have to be equal. All right, so now given that information, we would say if segment BD is a median, then X has to be equal to 9. Okay, because if they equal each other, CD has to be congruent with DA. Right? CD has to be congruent with DA. If that's a median, that means it cuts those into two equal parts. All right, so that's the basics of that. Those two items, angle bisector and median. Okay, so what I did over here is I highlighted our answers in green, and then we put our vocabulary words. We said bisect splits into two equal parts, angle bisector splits into two equal angles, median splits it into two equal segments, and then we talked about if it's an angle bisector, we're going to use our proportions, and if it's a segment bisector or a median, we're just going to say these two segments are equal. Okay, so go ahead and do these two practices in Delta Math before we move on to our final practice. All right, folks, let's, now we're going to put everything together onto our final practice. Now, we've talked about these two terms, perpendicular and bisector, so let's go ahead and talk about that exact definition. So a perpendicular bisector is going to be a segment. It's a segment, a line, or ray that goes through the midpoint with perpendicular slope. With perpendicular slope. Okay, so if we look at this line right over here, this line right over here is a perpendicular bisector. Okay, so it says find the equation for the perpendicular bisector of a line whose endpoints are -1, -8, and 7, -2. So on this problem, what I've done is this is what our answer is going to look like. This is what our answer looks like. Okay, that's what they're asking for. If they give us these 2 points, right? If they tell us -1, -8, if you look at it, it's right over there and right over there, and they want the perpendicular bisector, we said it's going to be perpendicular, so it's going to be at a 90-degree angle, right? And that it bisects it. So we're going to say that these two are equal, if that's equal to that. Okay, so that's how we would look at it and do it. Let's talk about it mathematically. So I've broken it down into 5 easy steps over here. All right, so let's follow these 5 steps. All right, so the first step that we're going to do is find the midpoint of the segment. So we remember from last semester, we said the midpoint formula is this right over here. So let's go ahead and do that first. The first thing is we're going to find the midpoint. So midpoint, we know we just have to remember that x comes first and then y comes second, right? So let's first calculate the x value. So we're going to say the x is going to be equal to the x plus the x divided by 2. So if x is first, we're going to say negative 1 plus 7 divided by 2. Okay, if we put that into our calculator, that's going to give us 3. Okay, now the y value, okay, we remember we can't put this whole thing in our calculator. The y is going to be the y plus y divided by 2. So we're going to say negative 8, because y is the second value, negative 8 plus negative 2 divided by 2. So y is negative 8 plus negative 2 divided by 2. And that's going to be equal to negative 5. Okay, so our midpoint then is going to be 3 comma negative 5. Okay, now what I want to do is I want to just circle that for right now, because that's something we're going to use later. It's not our final answer, but we're just going to circle that. Okay, so next, step number 2, calculate the original slope. So the slope form that we talked about is y2 minus y1 over x2 minus x1. Once again, we're just going to remember x is the first term, then y is the second. So on the second one, step number 2, we're going to say the slope is y minus y. So we're going to say negative 2 minus negative 8. Negative 2 minus negative 8 over, since we started with negative 2, we're going to start with the 7. So 7 minus negative 1. 7 minus negative 1. So don't forget about these double negatives right over here, right? So if we just type that into our Desmos, that's going to give us the answer of 3 over 4. Okay, so I'm just going to circle that as well, because that's our intermediary answer. All right, next, 3. We're going to calculate the perpendicular slope. Now remember, we said perpendicular lines are like this, right? That means they cross at 90 degrees. All right, so the slopes are opposite reciprocals, right? Reciprocals. All right, so we remember opposite means we're going to switch the sign. Okay, and reciprocal means we're going to flip the fraction, right? So what if I told you that I want you to find the perpendicular slopes of these two? So pause the video for a moment and see if you can get both of these. All right, so the original slope is positive 1 over 4. So the opposite reciprocal would be negative 4 over 1, right? Or we can think just negative 4. Okay, so either one of those would be good answers. Okay. Now, what about negative 3? Okay, common mistake is to say positive 3, right? But that's wrong. Here's what we want to do. We want to think negative 3 over 1, right? Because then if we do that, instead of negative 3 over 1, it's going to be positive 1 over 3, right? So that's what we want to think. All right, so that's what we're going to do, is we're going to calculate the perpendicular slope. So what we're going to do is we're going to use the slope, and let's just say M1, right? This would be our first slope. We're going to use the slope that we found from the original line. So the original slope is going to be 3 over 4, right? So if the original slope is 3 over 4, that means the next slope is going to be negative 4 over 3, right? So that's going to be the opposite reciprocal right there. All right, so let's go ahead and circle that one. That's what we need, is the second slope, right? All right, moving right along. Next, we're going to put that equation in point slope form, right? So we're going to use the midpoint and the perpendicular slope. Okay, so that's the key. We're going to use the midpoint and the perpendicular slope in our point slope formula. Remember, we're going to substitute right over there, and right over there. All right, so let's do that. Number 4. We're going to say y minus, and we said we're going to use the midpoint, right? So the midpoint was 3, negative 5, so the y value is negative 5, right? Equals, and then we said the slope, from our perpendicular slope, so not 3 over 4, we're going to use negative 4 over 3. Okay, times x minus, right? Don't forget the minus, the x value. So the x value is positive 3, right? So we're going to have 3 over there. All right, so that's step number 4. Now, one thing is we may want to change that double negative, right? So let's say that's y plus 5 equals negative 4/3 times quantity x minus 3. Okay, and let's circle that because that's what we'll use. All right, next we're getting very close. Now we're going to do step number 5. Now we're going to solve for y to get to the final answer. So remember, solve for y is getting into slope-intercept form, right? That slope-intercept form is when we get to y equals. So as we look at right here, we don't have y equals. So let's go ahead and copy that back down. Y plus 5 equals negative 4/3 times quantity x minus 3. That's how it's pronounced. So here's what we're going to do is we're just going to start over here first, all right? It looks kind of crazy maybe, but it's not very difficult. All right, we're just going to say we're going to multiply this negative 4/3 times the x and then also times the negative 3. Okay, so if we put this into our calculator, negative 4/3, well, times anything. If we say x, we can't put that in there. If we type that in, it won't understand that. But negative 4/3 times x is just negative 4/3 x. Okay, now negative 4/3 times negative 3. We put that in our calculator, that's going to give us positive 4. Okay, so if you just put that in your calculator, that's what you're going to get. Okay, then we're just going to bring this down, y plus 5. All right, so now we're getting very close. We want to get y by itself, so we're going to add the opposite of that 5. We're going to add a negative 5 right over there. All right, and we're going to have negative 5 right over there. Those cancel out. So y equals negative 4/3 x minus 1. Okay, so now I'm going to box that. And I'm going to put that in green. Oop, I'm going to highlight that in green because that's my final answer. Okay, so I know this is a little bit tricky, but I know you can do this. It just takes a little concentration, right? So when they want us to write the equation for a perpendicular bisector, we're going to do this first. We're going to find the midpoint, okay, first. Then we're going to find the slope of the original line. And then we're going to find the perpendicular slope because it's just going to be the opposite reciprocal. Then once we have the point that we're going to use and the slope of the new line, we're going to use our point slope formula. Once we have it set up, we're just going to solve for y. Okay. Then before that, we had our previous example. So if you look back on it now, you may see that the only thing that we highlighted were our vocabulary words, and then we used a special color for our final answer. All right, if you have any questions, just let me know. You got this. Make sure we do this before you leave.